Hey, hi guys, welcome to my channel. So in today's video, we'll be discussing more about pandas. This is probably the last chapter of pandas where we'll be discussing about the different ways to join data frames, so different ways which you can concatenate and merge data frames. Suppose we have these two data frames, right? DF1 and DF2. Okay, let me run this. So DF1 has column names as AB and DF2 also has column names as A and B. Now, if I want to join these two information, how do I join it? Right. So if I want to join them, I can simply do pandas.concat. I think we came across a similar function in NumPy arrays as well. Once you use this, you have to put both of the data frames in a list. Okay, df1 comma df2. And by the way, you can join n number of data frames. Like I'm just taking an example of 2. Since both the column names are same, I'm going to stack it one over the another, right? I cannot join it sideways. I have to join it, row wise. That makes more sense because both the columns are the same. So df1 conjugate df2. If I do simply this, you can see here all the values got added again. However, if I put comma x is equal to 1, it does axis wise concatenation. Here it does not make much sense because you want to add row wise. So by default x is always equal to 0. So I can simply directly do pd.concat of this. Now, one more thing which I want you guys to understand here, that when you concatenate, the index has remained the same, right? It has maintained the index which was coming from the second data frame. But I do not want it like this. I would want this index to be, serially indexed, right? So how do I do that? If I simply do here dot reset underscore index, you can see here, now we have the new sequential index, and the previous index got appended as a column, similar to what we found in, I think, one of the functions which I was using in data frame before, right? Pivoting or somewhere, forgot. Same way, you can just put here drop is equal to, if I do this, the index gets resetted, and then you can have all the indexes in the sequential manner. So this is how pd.concat works, a very simple level of joining row wise. Now let's take some more complex scenarios. Suppose we have these two data frame, okay? One is called product and one is a customer, two column names. Sorry, two data frame names. One has information of products. What is the product name? What is the product ID, category, price, and seller city? And the other one is a customer information, like customer ID, the name, the age, product ID, purchase product, and city. Now, if I want to join these two data frames and make it more meaningful, derive more information out of it, how would I do that? Whenever we come across such complex problem statements, we use a function which is called as merge. There are other functions which are very similar to it, which is called as join. So pandas has got join function as well as merge function. Personally speaking, I typically, use merge always, actually, because the syntax is very simple and it's very easy to understand. So join also works in the very same way. Similarly, you can do join as well. But let's first start with merge. Join you can explore later, because once you understand merge, join is, you can easily pick up join. Right. So let's start with merge, which I personally use a lot. So now if you look at the column names here, okay, product ID is the same. All right. Product name is not there because this name is the customer name. This is the product name, two different attributes. Category is also not mentioned here. Price is not mentioned here. Seller city is basically the same because the seller city and the city is the same. Now, if I want to join these two data frames, it does not make sense if I join it row wise, right? I have to find out a logic to join them. The logic should be the common column name, which would link these two data frames. The common column name, which will link these two data frames, right? What's the common column name here? We have product ID, of course. We also have seller city, right? Now, if I simply do pd.merge, okay, on df1 and df2, okay, this is on df1, df2. Let me make this product and customer, fine. Product and customer. If I simply merge it like this, right, you can see here on product ID, it has joined all the information out. However, we should not, take a risk. We should always mention which column you want to use to merge these two data frames. So column name is product underscore ID. But if you look at the data frame size, it has reduced, right? It had it has 9 observations here. It had 7 observations here, but what I'm getting here is 4. Seems to me that it has taken only the common product IDs, because in both the data frames, how many common product IDs are there? Let's see. We have 101, we have 106, 103, 104, and 107. So these 106, 1, 2, 3, 4, and 5. So there are 5 product IDs which are common to both these two data frames. 0 is not present here, of course, and the other ones are not also present here. So by default, it gives you an inner join or inner merge between the two columns. What is inner join? So basically, if I have two tables of information, and if they have some common, information present, it will only extract those information which are common to both these two columns. Now I know that purchase product belongs to the customer table, not the product table. I understand that. But here I'm not talking about the columns which are common. We're talking about the information which is linking both data frames which are common. So those product IDs which are common to both of them, only those will be taken into consideration. That is meant by inner join. So by default, it does inner join basically. So if I want to extract all the information out from both the tables, how will I do it? There's another argument called how. And how basically tells you what logic you want to use to join them. Say outer. And immediately we'll see the number of observations increases. Why? Because it will take into account all the product IDs which are there in both the columns. Common ones as well as non-common ones. So 0 is not present in the previous data frame, which was product, right? Correct. But still, everything will pick it up. And those columns which do not have information regarding with respect to this 0 will be filled with NaN values, missing values. Because product name, category, price, sellicity, these 4 columns belong to the first column where 0 product ID was not present. And hence we have NaN values here. Similarly, for our data frame, whatever product IDs are not here in the customer column, but are present in the product column, will be placed with NaN values. Because ultimately, it has to list out all the product IDs. But if you think about it, probably city would have been also same, right? But one is seller city and the other one is city. So the column names are different. There's one way of doing it. Either you rename one of the column names of both these two data frames, so product and customer, as the same column name. So product dot columns, if you see, and customer dot columns, seller city and city. Correct. So what I can do here is basically either I can change seller city to city or city to seller city, whatever you want to do. You can do that, no problem. How do I rename columns? So if I do something like this, product is equal to product dot rename whatever columns you want to change using a dictionary. Say seller city should be replaced with city. And also you have to do x is equal to 1 because you're looking for these names in the column indexes. Okay. Let me make it as product new. Okay. So now if I look at the product dot columns, seller city has been changed to city. Next, we can easily do on both product ID and this will be product underscore new, because product underscore new has the same column names. Okay, so as soon as you use city also as joining criteria, the number of observations increase, probably because both of the cities were also different in different scenarios. Earlier, we were joining only based on the product ID. Now we are joining also based on the city. So wherever city is not matching, it will again include NaN values. Here, they were both the columns, seller city or city. So Delhi and Mumbai are not same. That's why we had 2 columns, no problem. But since Delhi and Mumbai are not same, if I use city also as a joining criteria, then Mumbai will be another observation, Delhi will be another observation. Wherever the other is missing, it will fill up with missing values. So this requires practice, guys. Okay, looking at the video probably at one go, you will not be able to understand. I'll attach the code in the description. Please go to the previous videos also to get a hang of it and understand better. If you have any questions, put in the comment section. I'll definitely answer it. Right? This is one way of doing it. But to do this, to put city in on, we need the same name in both the columns. Can I join it without changing the column name in one go? That will be even easier, right? Yes, it's possible to do that. How will I do it? So again, product dot columns and customer dot columns, right? Instead of directly putting on, I can say that on is this. Okay. What I can do is I can put left underscore on, which means left data frame. This is the first data frame is typically referred to as left. So two circles, two Venn diagrams, left and right, right? So left on is product ID and seller city, whereas right on is product ID and only city. Let's see here, seller city. Okay. Product and this will be product, sorry. So we get the same result. It's just that without this step of renaming it, we can directly use right on and left on to do it. When you use left on, right on, it will accommodate, it will allow you to join on column names which are not same, but of course, intuitively from a user's perspective, you have to understand that both attributes is giving out the same information, just that the column name is different, right? But don't just do it randomly on two different attributes with totally different data types. Please don't do that. So here we can already see that one is seller city and city. So basically mean both of them are names of cities. It's just that the column name is different. So I used city to join both the data frames. Now this is a much more consolidated information. So similar, I can change to inner. I can also do left join and right join also. Left join will take into account not only the common elements from the left data frame, but it will not include the other product IDs or cities which are not present in the left data frame. So product ID, if you look at it, there was 0 in the right data frame, right? Not in the left data frame. So you pick up all common product IDs along with those product IDs which was not present in the right data frame. So in right data frame, 107 product ID was not present. And that's why you can see here, it is filled with NaN values. Same goes for city as well, right? However, if I do it right, it will not only pick up the common elements, also it will not pick up the ones which was present only in the left data frame. So we'll see more NaN values on the left part, not on the right part. So 0, you can see here, 0 is coming from the right data frame actually, right? Which is not present in the left information. So all these columns just present in the left data frame didn't have information with respect to 0 and 101, 106 information maybe, right? So it is all filled up with NaN values. Clear? So this is exactly how we do it. Use the data frame which I've used in this particular video. It will help you understand in much more clearer way. I've seen many tutorials using very complex data frames to help you explain. Try to understand from the basics first. Then you can always explore more data frames, right? Once your basics are clear, you can deal with any level of information. Doesn't matter, but please understand when you merge, typically we use two data frames at a time. Okay. Whereas concatenate, you can join any number of columns, provided all the column names are same. Again, you can join it row wise. That makes more sense. This is all for today, guys. I hope you enjoyed the session. We understood how we can merge two data frames or join or concatenate to different stable structures so that we can derive more information from it and we can make it more meaningful. Okay, in the real world also, in many projects, I had to deal with merge functions which come in very handy, especially in consolidating information from various, data sources, right? I hope you enjoyed today's session. Wish you all the best. And please keep watching my videos. And if you like my videos, please help us in sharing it to as many people as possible. Like, share, and subscribe. If you have any questions, put in the comment section. Please go to my description. It has got the playlist for the foundation as well as the cricket analyst playlist as well. Thank you for watching my video today. See you in the next one.